Well, hello and welcome. My apologies for the late start today. My name is Jonathan Gifford. I'm the editor-in-chief of PV Magazine Global, and welcome to this PV Magazine webinar. Well, as solar power moves from being a minor contributor to a major player in electricity networks in many parts of the world, it's becoming increasingly important to know what's going on inside a PV power plant today and also well into the future. The title of our webinar today is Output Verified, Monitoring of the PV Power Plant from the Ground Up. And we have 4 speakers that will provide us with insights into the cutting edge of what's expected from project performance and monitoring, and ways in which new digital tools can deliver on those expectations. Our webinar today is delivered in partnership with Trina Solar, and we'll also bring you an exclusive demo of the Trina Smart Cloud platform today. It's actually the launch of the platform today, so this is a great opportunity. Please do stick around for that. As I mentioned, we have 4 speakers joining us today. Alberto Sanchez is a senior key account manager for TrinaTracker EU. Julio Fernandez is an IT manager with TrinaTracker. Ni Yushin is the product manager, Trina Solar Cloud Internet Energy, and Christoph Reiners is the head of product management, ground-mounted PV and tracking systems for Baiwa Ari. Thank you very much and welcome everyone today. Now, before we start the presentations, you might be joining a PV Magazine webinar for the first time. So welcome to our webinars. And once again, apologies for the delay, a few technical problems in the background. Internet connections are not always what they should be. But here's some info about how you can get involved today. And I really do encourage you to be a part of our discussion, to ask questions at any time throughout the webinar. I'll be feeding them into the discussion, and we'll also have a quick fire Q&A round right at the end. So stick around for that and please do get involved. If you experience any technical problems, I hope not, but as I said, the internet isn't always as reliable as it could be. You can simply ask a question of our tech team who are standing by to assist you. You can do that in the question function, the same way you can ask questions of our presenters today. A quick tip is that if anything goes wrong, simply refresh your browser, and that fixes a lot of the problems. One question we always get is, will a recording or the presentations themselves be available after the event? And the good news is yes. Keep an eye on your inbox, as we'll be keeping you up to date via email. Well, let's get going straight away. Thank you, all of our presenters. Once again, let's have our first presentation, which is Alberto Sanchez, a key account manager with TrinaTracker EU. Alberto, I'll pass the stage over to you.
Attending this webinar today, and thank you for having me. I will be introducing our company. I'll give a brief introduction of the company and the main products that we have in the market. So TrinaTracker, we have been in the business for more than 17 years, and our trackers are installed in more than 40 countries worldwide. We have a total of more than 7 gigawatt of trackers installed, as I said, worldwide. Our main production centers are in China and Spain. However, we're always looking for new suppliers close to our clients' project sites. Our trackers has been designed to be installed in any kind of terrain and any kind of weather conditions, including extreme weather conditions. And our tracker as well are compatible with all kind of modules, from the small ones of 450 watts to the high energy modules of 670 watts. So our 2 main products that we have are our single row 2P, we call it Vanguard, and our dual row 1P, we call it Agile. Beyond that, it's worth to mention that we also manufacture and deliver fixed structure racking systems. Some figures about our 2P single row tracker. We have optimized the design of our piles. We have now 7 piles in the inner rows and 9 piles in the outer rows. Our torque tube as well is stiffer. We have now a torque tube for 170 millimeters. And we are using a multi-drive system that allows us to block the whole tracker, not only in the motor pile, but also in secondary piles. So with this feature, we have a tracker that can withstand high-low winds as it is blocked in several points along the torque tube. We have also a spherical bearing, but the spherical bearing, which is patented, and it allows us to have easy mounting on the side. We have an area stability of 30%, so this save time when installing the tracker on site and makes the installation much more easy. Trying to move this. Okay, for communications, we can either have wired communications or wireless communications. For wireless communications, we use either Zigbee or LoRa. And finally, we have developed, and we are including this in our trackers. We have a super track algorithm, which increases the energy output of the plant from 3 to 8%. I will explain later a little bit about this algorithm in the next slides. So some of the figures about our 1P double row. We have a slew-in drive system with a card and bar connecting both rows. This card and bar can be removed for operation and maintenance works and can be replaced again. For fixing the modules to the structure, we use the Trina clamp. It is also a patented item, and it makes the installation or the fixation of the module to the structure very easy and straightforward. Our torque tube in this 1P is also stiffer, and we also use the spherical bearing, as I said before. Regarding the piles, we try to use C piles whenever it's possible. Whenever we have difficult terrain, we can also go for W or H piles. We have performed the wind tunnel test on our two products with the main energy consultancy firm in this field, RWDI, that probably you all know, and CPP. So we have not just performed or carried out the wind tunnel standard test, but we have also gone the extra mile, and we have carried out the 2D sectional model test and numerical model. This test allow us not only to calculate the critical wind speed for the prototypes that we are testing, but also allow us to have several parameters of the tracker and the results. And last but not the least, we have performed as well the full aeroelastic test, which confirm the results obtained in the previous tests. So wrapping up the part of my presentation, we have optimized most of the components of our trackers. We have included high technology software solutions, the one that I mentioned before, the super track algorithm, which is made of two core algorithms, the smart backtracking algorithm. This algorithm optimizes the angle of the tracker. When we have a cloudy day with high diffuse radiation, we optimize the angle of each tracker to maximize the output of the plant. And the second one is the smart tracking algorithm. The smart tracking algorithm takes into account the terrain and increase or calculate the optimal tracking angle to have the highest energy output during the early and late hours of the day. We have also developed our Trina Smart Cloud that will be presented later on by my colleagues. And we have not only optimized the design of these items, but also the number of these items on our trackers, minimizing as much as we can. So all this reverts on a lower balance of system cost, a lower operation and maintenance cost, and a higher energy output of the plants that are used in our trackers. So that's all from my side.
Perfect. Thank you very much, Alberto Sanchez, a senior key account manager for TrinaTracker EU. I don't have any live questions. Our next presenter is Julio Fernandez, an IT manager with TrinaTracker. Cybersecurity is a big issue these days, and when we're talking about the cloud, there's lots of questions relating to that. So Julio, I'll pass the floor over to you to take us through some of these aspects.
Thank you, Jonathan. Well, thank you for having me in this webinar. First things first. Basically, I'm here to speak a little bit about the Internet of Things. For those of you who are not familiar with the concept, the Internet of Things by concept is basically referring to a system of interrelated, internet-connected objects that store and manage data, and basically improves the efficiency and the performance of such items. You can think of it as the day-to-day life items like the display TVs, home appliances, vehicles, sensors, or in this case, solar panels. Basically, this technology can be applied everywhere, and it has dramatically changed the world in the latest years. And it's not just about connecting things, but it's about the fact that the system stores and processes the information to improve its performance without the human intervention. So, in the energy sector, which is the part that interests us, the IoT devices have been used to create an intelligent network throughout the collection, transmission, and the use of these large quantities of data. And this enhances the possibility of controlling the real-time operation of your plant, making possible to accurately estimate the behavior of the system in the future. For example, the question that arose earlier, how can you apply this technology to the trackers? Well, maybe if there's any failure on the device that might be prevented or that happened in the past, it can be forecasted by a machine learning or intelligent system like this, and to warn you, like by a certain amount of time, letting you know that you might check this or check that without having to regularly check yourself the hardware. As you can imagine, this technology has changed the way the industry works in the photovoltaic world. Basically, homeowners with solar installations can now easily determine if the system are working correctly, and solar companies can view data from the edge across the full range of solar assets that they have. The more panels and the batteries that you have, the more complex it becomes. But with integrated monitoring and the IoT technology, it's possible to see degradation and points of failure before it happened, and even onto a specific panel. At that level, you can see failure. So it's pretty detailed, and the quality of information is pretty granular. You filter a lot. You iterate with a lot of data, and the algorithm that we work with in the cloud, of course, are thought to be improving among the time. So part of the technological challenge for not only the energy sector, but for all the society as a whole, comes down to effectively transition from a traditional way of handling with issues, where you had a reactive attitude. When something broken, you have to fix it, to a proactive one, where you can prevent the behavior of the device. So before it breaks, you can make something out of it. So as you can imagine, the amount of advantages this gives to the photovoltaic world is a lot. I mean, there is a wide variety of appliances where we can basically implement these sensors in a plant and collect all sorts of data, environmental data from the device itself, and to forecast not only the energy consumption, but the energy saving, and how much do you need for doing the work, and how much are you going to generate over a certain period of time. You can also calculate the amortization period more effectively, and you basically save a lot of problems for visiting the plant when it's in a remote location. Having the possibility to manage this from remotely is always something more comfortable, technically easily to do. Of course, network security has to be up to date in all these things. When the technology evolves, so do the risks. So you need to have a strong network security team working behind you, and the latest, of course, the latest software and the latest hardware from the vendors. Here you can see basically a couple of key concepts. What I like the most is the concept of the intelligent building or the intelligent city, where a city can basically handle itself their own energy needs and provide all the users, making calculations for an entire human population of how many energy are you going to need and how to provide to them. I find that really good, really amazing. After all, everything comes down to a combination of factors that make this system efficient and worthwhile. Basically, the idea of the intelligent building or the intelligent city that I mentioned before can be applied in the enterprise and can be applied in a PV plant. There is a lot of end users, and the scope for this is infinite. As I said, in particular into the photovoltaic industry, the most you will see later on in the presentation how amazing is it, the level of control that you have under not only the devices but what's around them, the environmental, because there is a lot of factors that you must take into consideration, and basically having the chance to let the machine think about it and let the internet think about it is what amazes me, because this is going to continue in the future. This automation trend, doing things before they happen, is going to continue, and I'm basically amazed to see what is yet to come in this regard. And that would be it, Jonathan.
Thank you, Julio. Okay, we have some live questions coming through, but I don't think they're particularly relevant to you. So I'll take one that was sent through at the registration stage. Can you give us more detail as to the features of the Trina Cloud cybersecurity?
Yeah, well, basically, of course, as I said before, you always need to have a strong network security team before you, to ensure that you are using the best encryption methods. Basically, you protect your infrastructure with a firewall, and that, depending on the configuration of the device, you can have control over the traffic that goes over that wire. So the communication always has to be a first priority in any enterprise that want to implement IoT into his plant. And we, of course, take it very seriously.
Okay, one more question, Julio. From your experience, what kind of typical attack patterns have you observed out in the field, and what do you do about it? And by attack, I assume that's cyber attack.
Yeah, well, my experience has been more related to the day-to-day users. So basically, the most common way for someone to be attacked is to commit an error, a human error. Basically, we called it UI, which is user incompetence, and that defines it pretty well. When you see someone who is asking for your password, don't trust it.
Sure, exactly. Get one of those emails. You have not won the prize, and you are not in store for an inheritance that you didn't know about it. Julio, thank you very much for your time. Stick around for the quickfire Q&A round at the end. Now, as I said, and Julio has also alluded to, we're going to get a demo now of the Trina Smart Cloud joining us from China. It's my great pleasure to introduce Ni Yuxin, the product manager, Trina Solar Cloud Internet Energy. This product was just launched today, so this is fresh to everyone here. Ni, are you there? Can you hear us? And join the presentation now if you can.
So today I'll do the introduction for the Trina Smart Cloud. And so what is Trina Smart Cloud? Trina Smart Cloud is a next generation smart tracking control system, which enables to remote monitoring and cluster control of large-scale PV tracking arrays, which can be used in two scenarios. First is the numerical solar control solution, and another one is providing a centralized smart operation and maintenance solution, which can provide real-time monitoring and alarm management, and data online analysis and remote controlling, system diagnosis, and smart operation and maintenance. And for how Trina Smart Cloud can benefit O&M, if the operation for the operation and maintenance staff, if the Trina Smart Cloud is adopted in the PV power station, realize digital intelligent real-time monitoring, which can benefit O&M by monitoring PV plant in real time and remotely, and reducing management costs. Realize real-time and rapid data online analysis can benefit O&M by providing O&M suggestions and improving the reliability of PV power plant. And monitoring real-time alarm detailed information can discover faulty equipment in time and take effective measures. And finally, remote precise control and command can benefit O&M, can improve the O&M efficiency and greatly reduce the total costs. And so how does Trina Smart Cloud reduce LCOE? It mainly comes from three functionalities. Firstly, Trina Smart Cloud is integrated alarm protection, a cleaning robot, and the smart tracking algorithm, and do diagnosis and analyze for performance ratio for the PV power plant, and which make it effectively reduce power loss and improve system efficiency, so as to realize power saving. And secondly, by quick troubleshooting and quick remote commissioning and easy to set deployment. In this way, O&M efficiency can be improved and the O&M cost and time can be greatly reduced so as to realize O&M saving. And finally, because Trina Smart Cloud system can provide data package, API, and highly visualize the human-machine interface and mature customized configuration. Which makes Smart Cloud become a user-friendly software and easy to integrate to other platforms. And in a word, Trina Smart Cloud is an intelligent solution that's easy to integrate software and hardware and greatly saves power generation loss and fault location time, which makes this system effectively reduce LCOE. And then why does Trina Smart Cloud drive smart O&M? If Trina Smart Cloud used in PV power stations, this SCADA system will drive smart operation and maintenance through data monitoring and execution, online analyzing, and remote controlling. But about how to drive the smart operation and maintenance is mainly reflected in the following three parts. First of all, based on the historical alarms, the fault diagnosis of system will be achieved and the operation and maintenance suggestion will provide. After that, it can do the PR analysis and provide recommendations to power stations according to the health status of PR value. At the same time, it's easy to compatible with and control the intelligent cleaning robot to the PV modules. So, as a result, Trina Smart Cloud can effectively drive smart O&M. In addition, Trina Smart Cloud will also bring better system operation efficiency and higher power generation quality, lower system costs, and the smart operation and maintenance effect to the system. And next is the video.
As a global leading provider of total solutions for PV smart energy, Trina Solar offers its integrated Trina Smart Cloud system that enables PV power stations to reduce costs and increase efficiency. And Trina Solar provides comprehensive services and fast system integrated delivery. The Tongchuan PV tracking project equipped with Trina Smart Cloud system has become a high-tech top runner base. Through intelligent interconnection of hardware and software, Trina Smart Cloud monitors the entire station in real time, obtains equipment operation status and exports operation reports according to customer requirements. Through real-time data collection, online analysis, and PR diagnosis, the system swiftly identifies abnormal and faulty equipment and offers maintenance recommendations. This ensures efficient and stable operation of the entire power plant whilst reducing O&M costs. In the case of abnormal tracker operation, Trina Smart Cloud sends remote control instructions to NCU. in time to adjust the TCU working mode and target angle, achieving remote and accurate control of the power station. Combined with the weather forecast data, Trina Smart Cloud utilizes stow strategies for extreme weather conditions by adjusting the tracker to a target protection angle before strong wind, rain, snow, and hail. It ensures system resilience against extreme weather events. In the future, the use of big data and artificial intelligence algorithm will perceive and predict equipment operation status, opening a new chapter of intelligent tracker operation and maintenance.
That video gave us a few insights into how it works. Nee, you're back again. If you could continue with your presentation. We've seen the video now. If you could continue.
Oh, okay. Okay, so this is the login page. On this page, you can enter the account and password to log in, and then log into this page. So after logging to the system, firstly enter the global distribution of the PV power station, which contains the following monitoring elements, which are the number of stations and the value of installed capacity, active power, the total generation, and the carbon dioxide emission reduction, and energy saving and the emission reduction of PV power station is equivalent to how many trains are planted, and generating benefits and the performance ratio of the PV power plant. So there is the Earth placed in the middle. You can rotate the Earth to find that there are two PV power stations, Tongchuan and Fuxing. And when the mouse floats on the icon, the specificity monitoring data of this PV station will display, which are active power, installed capacity, total generation, and the total benefits. And here I'll take Tongchuan PV plant as an example for the demo showing. Click on here to enter the home page. So here is the home page. This page focuses on the key index data of the large-scale PV tracking array, including the meteorological data such as the real-time wind speed, irradiance, temperature, and weather, and the data statistics of each tracking TCU working mode. And in the middle is the overview of PV station. This is the map of Tongchuan PV plant. Here we did data allocation and monitoring from 3 arrays, the 35, 37, and 44. And you can see the communication status of NCU and all its subordinate TCU's communication status is normal or not. And on the right is the overview of the power generation. You can see there the value of power generation, the full output hours, and active power. And then here is the statistics data of TCU and NCU according to the alarm types, so as to realize the unified operation and monitoring and the centralized data management of large-scale PV tracking array, and provide comprehensive data and services for operators, maintenance personnel, and managers. And then the next part is the monitor. Firstly, the survey. So, yeah. And in this page, in this part, the general situation of PV station working is displayed in different time dimensions. You can see the day, month, year, and total. And so on the left, you can see it's a comprehensive analysis and statistics of the communication status of all different types of devices in the whole PV power station. You can see the communication status, normal, COM loss, and fault. And here is the statistics index parameters like installed capacity, temperature for output hours, and some other parameters. And here is the curve between active power and the irradiance, and the total irradiance and the power generation, and the value of performance ratio of this PV power plant. And at the bottom is the equipment availability and the ranking of PV string inverter based on the value of the full output hours. And so the PV station survey can realize centralize the statistical analysis of real-time data and historical data, and improve the operation reliability of the station and equipment. And next is the device list. This section focuses on the monitoring of all devices and displays the communication status, like no communication or normal, and the operation parameters, and alarm, and the description of alarm or event of different devices, which are the NCU, TCU, transformer, inverter, PV string, and weather station. Yeah, and for each list, each list page supports export and the query function. Besides, the parameters can be configured as what you want to have a look. And so in this way, the operation monitoring and centralized data management of the large-scale PV plant can be realized. Meanwhile, the management costs can be effectively reduced. And if you want to see the device details, click the Enter button to jump to the details page. Yeah, so here is the detailed page for the NCU. It shows which working mode the tracker NCU is in, and the specific operating parameters such as the running state, the fault information, wind speed, optimization angle, group control angle. And here is the geographical distribution of all TCUs subordinate to this NCU. You can see that there are 37 TCUs. In this part also presents the TCU's running state, the normal, COM loss, or alarm, and running mode. You can see all the TCUs are in the automatic mode, and the control angle, which includes the target angle and real angle. And at the bottom is the real-time wind speed curve and the alarm information. In addition, if you want to see other device details, you can also use the query function to have a look based on the device type and the device name. Click search. So here is the detailed page of this TCU. It shows the TCU's working mode, the operating parameters like historical alarm number and the value of target angle and actual angle. And here is the relationship between the actual angle and the target angle, and the TCU's operation information, which are the east limit angle and west limit angle. And there is the distribution of this TCU in this position of this TCU in this array, and the diagram of alarm information, such as inverters detailed page. This is the detailed page of inverter. It mainly displays the configuration information of this inverter, like the brand, the model, the MPPT number, string number, and the capacity, and real-time operation monitoring, the DC side value, AC side, and the internal temperature and conversation efficiency. And and the relationship between dispersion rate and branch current, and the curve of the power generation. Here is the alarm information of this current inverter. And for the data analyze part, um, uh, collect the consume custom analyze button to enter the configuration tool. You can analyze the data based on the select object. This is Tongchuan, and the data indicator like power generation and irradiation, and the display mode, the line chart or the bar chart with different color. Yes, and click confirm. Then you can see the curve analyze and the data sheet. By the way, the display data can be exported as a report. Thereby, this module will improve the working efficiency of the operation and maintenance personnel, and also realize the omnidirectional monitoring, analyze, and dynamic management of the whole PV plant, which can effectively have the PV station to make a reasonable operation and maintenance plan. For next module is the alarm information. This module presents the detailed alarm information of per TCU and NCU, which supports the centralized display of real-time alarm information. You can see this is the alarm time, the device name, and the alarm content. In the historical alarm information, it supports the query function. In this way, the inspection pressure of the operation and maintenance personnel can be reduced to ensure the normal and orderly operation of safe production. And the finally module is the forecast management. This module includes weather and the generation. And the weather forecast for wind speed and irradiance supports the data forecast of 1 point per hour in the next 48 hours. And for the power generation forecast, it shows the forecast of power and irradiance through curves and reports. At the same time, the data sheets can support export function as well. And in this way, this forecast module will effectively reduce the operation and management efficiency and economic benefits of PV power plants. Okay, so that's the demo showing for the Trina Smart Cloud. This is the inclusion of this Trina Smart Cloud. And Trina Smart Cloud is an intelligent, efficient, reliable, and safe application. And for the intelligent, Solar Smart Cloud is centralized intelligent algorithm to realize smart O&M tracking. And for the efficiency, Trina Smart Cloud can increase the performance and productivity with the power of comprehensive and reliable data. And in this application, we did the data execution and monitoring from a weather station, NCU, TCU, inverter, transformer, and PV string. And about how it does reliable, it enables reliable and precise operation across a wide range of weather conditions. About the save of Smart Cloud, it can do fault diagnosis and O&M suggestions in advance to ensure stable operation of whole PV station. So in a word, for the whole solar power plants, Trina Smart Cloud is a remote and advanced monitoring and control system. Okay, so that's all. That is all about the Trina Smart Cloud.
Amy, thank you very much once again. And as I was saying, great to get a demo, and really a world first demo of the Trina Smart Cloud and inside a real world project. Well, let's speak to a real-world project developer next. I'd like to welcome our final speaker before we enter the Q&A round, and I see some great questions coming in, so please keep them coming. We'll bring all of our speakers back. Christoph Reiners is the Head of Product Management, Ground-Mounted PV and Tracking Systems for BayWa r.e., project developer, and more recently, a project long-term owner and operator. So such systems are very relevant to you. Christoph, I'll pass the stage over to you now.
Thank you very much, Jonathan. Pleasure to have me. Hopefully for you, I actually enjoyed a lot to get this opportunity. So yeah, what I will be talking about today, it's about SCADA data at BayWa r.e. It's very fancy and fascinating how great the portal of Trina looks like, but I want to encourage you that you can do a lot more with your data if you own it, and get some special insights with an EPC, O&Ms, or IPP perspective. So maybe for the beginning, some words of BayWa r.e. Some of you might know us. BayWa r.e. is active in project development, both wind and PV. So we have a global footprint here. We take our stake in operations as well, O&M, classical O&M for third parties, as well as for our internal IPP portfolio. And last but not least, we're active in the field of solutions, meaning bringing tailor-made solutions to C&I clients all over the world, and including our solar distribution network as well. So data at BayWa r.e., it's very important. Nie just explained more from the O&M perspective what the Trina portal looks like. It was about optimizing reaction times, automated alarms, process-driven activities, the interlink between the control center and the on-site staff, automated reporting for sure very important as well. But there's more which can be drawn out of monitoring data. So if we consider our role as BayWa r.e. within the EPC business, I think about tailor-made solutions for commissioning, that we support our acceptance tests, for example. It's about PR testing. It's about a proper assessment if the plant design has been accordingly made. And last but not least, of course, the monitoring of our warranties. With a view from the technical asset manager, meaning our IPP experience, it's more looking into trends, which maybe here and there differentiates us from the O&M perspective. It's about OpEx optimization, again, design optimization, which is in line with the EPC view, and again, the warranty claims. So again, the existing solutions are mainly focusing on O&M demands, and we see an increasing complexity and system individuality. It's about trackers, it's about the orientation, it's about storage, the feed-in scheme, so forth and so on, which drives us into the direction that we have to become the owner of our own data, that we have to act on our own behalf to cover the EPC and technical asset manager view as well. That's why we have incorporated a new setup here. We are about to redirect the data from our plants. As you can see here, we are currently deviating the data which in the past solely went into the monitoring solution into our BayWa r.e. managed cloud. And from there on, it will be available to Python analytics or some internal API, which makes it available to Power BI solutions I will show later to you. And the final setup will be the case, or will look like that we bypass the monitoring suppliers, that we get all the data into our cloud hosting system, and from then on push it on to monitoring solutions, where we will always rely on third-party solutions. It's not our intention to reinvent the wheel here, but get the power over our own data and use it for internal investigations as well, such as the one I was mentioning before, especially aiming for EPC and IPP long-term use. So I will show you some insights where we had some special problems, and by taking over the power of our own data, putting it all into our data cloud, we were then able to find suitable solutions to our problems. The first one was that we had a data quality issue with regards to irradiance. That was an O&M task here in this particular case, where the question arose from. The solution was that we brought all the data into our cloud, that we build up a data cleaning mechanism, including also external data sources, and by that increasing the data quality of our sensors on site, because with this help, we were able to keep track on our data quality, whereas lots of the monitoring systems take care of alarm mechanisms for inverters and so on. We have here incorporated something which can help us monitor the quality of our data with regards to irradiance. Lots of guarantees are linked to sufficient data quality of irradiance sensors. Then the next problem which we had to face, where we had to find a solution, it was about EPC work, where we wanted to scrutinize the tracking and backtracking algorithms parameters of our supplier. So what we did, we get all the tracker data into our internal cloud service, shuffled the data and combined it with algorithms we can find in the PVlib. It's a MATLAB open source library, and where we could challenge the parameters set by our supplier and question if an appropriate tracking algorithm has been applied or will be applied. So just to double check and be in the position to question the system delivered by our tracker supplier. Then two other ideas where we could use our internal data analysis. The problem on the left-handed side, it was about the influence of topography on the backtracking. Again, it's been driven by a tracker issue. So what we see here, it's a visualization of the inverter production in the monitoring, especially in the evening and in the morning hours, as a function of the gradient of the plant with Python. Meaning we somehow made a link between the topography, which is normally not incorporated in a standard monitoring system, and the inverter productivity in the morning and in the evening hours when the backtracking takes place. And then on the right-handed side, our standard setup with regards to trackers foresees that 4 trackers are feeding 1 inverter, and we wanted to find out if one misaligned tracker has a bad influence on the inverter performance with regards to output. You see, maybe you can, it's not so easy to see here, but there is an outer square and an inner square which symbolize the unity of the 4 trackers and the inverter. And like that, we were able to visualize the playing together of inverter and trackers, and get closer to finding the needle in the haystack. So concluding my little presentation, what BayWa is having in mind. So we want to become the data gatekeeper. We want to decide who accesses our data or our client's data, where we take care of on behalf. Our general setup is that we are constantly screening the market for suitable partners who could be attached to our data source. Of course, these partners have to accept our data policy that we want to be this gatekeeper. And the other thing that we want to internally develop further ideas that do not fit the mainstream, because the complexity is, as I mentioned before, becoming more and more. So we have to make up a smart way and optimize our internal data researches ourselves, because we think that not every problem we face in our daily routines will be covered by an external partner. But in any case, we want to rely on good and professional partners who can contribute suitable solutions. The monitoring must-haves for BayWare, because we are talking about a monitoring system here at Trina. It's a must that all relevant components are can be reviewed in the monitoring system. We don't want to operate two systems at the same time. If I think of trackers and inverters, for example, so there must be the logical dependency incorporated that, for example, as I mentioned before, 4 trackers are feeding one inverter in the BayWare standard design, and they then form, for example, the unity which is then submerged under the transformer. We want the flexibility that we can integrate new suppliers, all OEMs, so not linked to one single inverter or tracker manufacturer. And we want to incorporate new technologies like storage. So it has to be really open that we can incorporate these technologies as well. And we need, which is very important, a proper criticality alarm assessment. So still, transformers are the highest day-to-day O&M routine. They must be properly reflected. A string inverter, of course, we want to see it as soon as possible, but the priority must be less. That's a daily O&M business. Tracking algorithms, very important as well. But if one tracker fails to find the optimized angle one day, I think it's acceptable. On a general view, the backtracking and the algorithms have to be in line, but it must be a proper hierarchy when it comes to alarming. And modules, of course, that's something for monthly, quarterly trend analysis. That's a super high priority as well, which is not so much being looked at in O&M routines, according to my experience. Then finally, which is very important to BayWare as well, it's that all solutions that we apply have to be in line with our legal IT security standards. We just successfully passed the ISO 27001 certification audit, which is about IT security. We implemented a information security management system, and of course, our partners who contribute to this environment have to be in line. Otherwise, we are running in a risk to lose our certification, and it's been work of 2 years. And we don't want to risk this. We want to stick to this policy. And that's it. Actually, from the BayWare perspective, really, I want to encourage you. Become the master of your own data. Do something out of it. It's not so complicated, actually, once you have the access. It's not looking as fancy as it Trina, but there's really lots you can take out of it. It's just get started, organize your data. That's my advice.
Okay, Christoph Reiner is the head of product management, ground-mounted PV and tracking systems for BayWare RE. Thank you very much. So, just before we go into the Q&A round, from the projects that you just presented, then the kind of data analysis projects, are you going in thinking there's something that's not quite right, either with the operation or with the data that we're getting, and let's figure that out? Or are you running kind of projects proactively to say, look, we're getting this information, what can we do with it? How can we play with this and then optimize what we're doing elsewhere?
Well, it's possible both ways you were describing. Currently, we are driven by tasks which arise from, for example, from commissioning, because the tracker technology is quite new to everybody. You get something from the EPC, and they say, hey, it's fine, and then it's up to you to find suspicious modes and react to this, because it's constantly changing. It's becoming more and more difficult. It's no longer the 180 degrees directed south fixed tilt standard plant. It's really tricky, and that's a challenge, but it's nice, and we have to adapt to this.
After the conclusion of this webinar, you will be receiving a survey, and I do encourage you to fill that out. That always helps us to create better webinars for you to meet your needs. And of course, don't miss out on the latest edition of PV Magazine that's just hit the shelves. You can use the QR code there to get a 10% discount, and keep up to date with PV Magazine online, PV Magazine Global. We have a wide array of market analysis analysis and insights from right around the world. Here are some of the most read articles that you can check out for yourself. And of course, stay in touch with PV Magazine to look at the full array of webinars that we have across our platform. Here are some of the upcoming ones, the last ones for 2021. More on trackers coming up, optimized stow strategy for higher yields in single axis tracking, and then agrivoltaics, which is a new and emerging field. I know that BayWa is active in that field, so Christoph might be joining us again from Sun to the Fork. How can the circular agrivoltaics boost solar's reputation and increase value creation for all? You can register to those using that QR code, of course, or just visit pvmagazine.com. Well, thank you once again for your attention today. Thank you for joining us. My apologies for the technical problems, but thanks for sticking in there. And I look forward to speaking to you again. My next webinar will be in the new year, so we'll see you in 2022. Bigger and better things for solar, harnessing big data, no doubt, getting more insights into how our PV power plants are performing and how we can maintain them long into the future. My name is Jonathan Gifford, the editor-in-chief of PV Magazine Global. Thanks for joining us.